So my name is Pierre Sokolsky. I'm a professor of physics at the University of Utah, and my field of research is experimental particle astrophysics. But what I really do is to study cosmic rays. So let me tell you a little bit about this mysterious radiation that is bombarding the Earth from outer space. So you may know that through your head every minute there is something like 100 of these particles going straight through your head, and they actually affect your biology at some level. They're called cosmic rays. Now, most of these particles come from the sun, and they vary as you have solar storms. But the ones that we're interested in come not even from our galaxy, but from other galaxies. And these are subatomic particles like protons or nuclei of atoms, and they have incredible energies. They're the most energetic objects in nature. They bombard the Earth's atmosphere, and when they hit the upper part of the atmosphere, they form a shower of particles. And this shower, this cascade of particles goes through the atmosphere and hits the ground. And what we do here at the University of Utah is we have an experimental station, a kind of observatory, out in the desert. And we actually detect these particles, the very, very high energy ones. They're very rare, so that we have to have a very large detector to capture these particles. And we've been doing this for about 30 years now, and trying to understand where they're coming from, what they are, but most importantly, how does nature actually put so much energy into this subatomic particle? The energy that these particles have is way beyond what we can do on Earth. You've probably heard about the CERN LHC accelerator and the Higgs particle. These particles are much more energetic than that. There's no way that we can, as humans, create that kind of energy on Earth. So it's really interesting to try to find out what is it in the cosmos that accelerates these particles. And right now we think that the best guess is that it is the so-called supermassive black holes in the center of galaxies. These enormous black holes that suck matter in, and in the process of sucking the matter in, they make jets of particles. And when that jet of particles is aimed at the Earth, then we see these cosmic rays. And we're beginning to get some really interesting information about where these black holes are, where the galaxies are that produce them. And this is now a continuing process. We are expanding our experiment. It's a big collaboration, it's international collaboration. So people from all over the world can participate. And this is a very exciting area of physics. And it's particularly exciting, I think, for underdeveloped countries, because you don't need very sophisticated equipment to begin to study them. You don't need to have an accelerator. You don't have to go to Geneva to work at the CERN accelerators. You can actually set up counters in your high school. And people have done this. They've actually gotten interesting data by making arrays of detectors in high schools, communicating between the detectors using the web. All kinds of. If you look on the internet, you'll find very interesting projects that can be done by high school students, by college students, and that will teach you a great deal about cosmic rays and prepare you, hopefully, for a career in the sciences, whether it's astrophysics or particle physics or nuclear physics. All of these fields have something to do with this cosmic radiation. So I hope you look into this and look at our website, which is also available and has an educational component, and think about your education in this area. Thank you.